Hello to everybody on the online version of All Things Open. It's a really great event if you ever get the chance to attend in person. If this pandemic ever ends, I know with Delta variant spiking, I decided to do the virtual version of this conference. So I'm excited to be here with y'all today on the interwebs via Zoom. We're going to be talking about making Angular apps more performant with Scully, which is a cool open source tool that you may or may not have heard of. A little bit about me. My name is Jennifer Wadella. You can follow me on Twitter at @omgitsfedi. By day, I am the director of Angular development at Bitovi. We are a small boutique JavaScript consultancy. So we really specialize and focus on the front end, and I lead our Angular team, kind of helping and coaching our clients do a lot of different things, among them improving Angular performance. And we have used Scully in the past where it applies. I'm also an Angular Google developer expert. And when I have my switch out, I would consider myself a pretty good expert tarantula catcher. I hope there are other Animal Crossing fans in the room because that's kind of the theme of this presentation. And Animal Crossing is definitely one of those things that got me through the first year of the pandemic. So love that game. And I am a fermentista, so I do a lot of kombucha brewing and fermentation on the side. Yay for fun hobbies. All right, I want to start this presentation talking about a great quote by Alexis Ohanian. I really like his book, Without Their Permission. If you're not familiar, Alexis Ohanian is one of the co-founders of Reddit. And in this book, he says, when all links are created equal, your ideas can simply win because people like them. The future of innovation will be made and not managed. And I feel like this is something that we kind of lose sight of in our industry, day in and day out. We're software developers, we're pushing code through, we're pushing features through. And sometimes we lose the magic of what we do, like just by nature of sitting at our computer and writing code, we can bring real things to life, with no cost for tangible materials or anything other than, web hosting costs in a lot of cases. And so I just want to talk about the power that we have as developers to just bring things to light, and those things can help real people as long as those real people can find them and get to them via the internet. So what this means is, you can have an idea, which you are going to create in your code. The next thing you need to do is help people find your idea. Traditionally, we do this through SEO, doing search engine optimization, so people can pop open Google or DuckDuckGo or whatever have you and find your idea on the internet. And then finally, to make people love our idea. And this is where performance comes into play. So when we talk about improving performance of Angular applications, one of the reasons is to get it to the user. But another thing we're going to talk about is like, how do we make this content more searchable? How do we get people to our great ideas through these optimization techniques? And where does Scully come into play through all of this? All right, so before we jump into talking about Scully, I want to talk about Jamstack. I think there are probably a couple tracks at this conference that are covering this from different avenues, so would definitely encourage you to get out and explore some things. But what is Jamstack? Jamstack stands for JavaScript, which is our application functionality. Probably across the vast majority of the web now, most of our applications are written in JavaScript. This is what a user's interacting with. This is what we are using to create our UI. So that piece of the puzzle stays. API, or A in Jamstack, stands for APIs, or server-side interactions. How a user is interacting with data, how we're getting that data from the server, and doing that in a coherent way. And then the M comes in with markup, statically served HTML files. And this is kind of the secret behind Jamstack is, we can build these really amazing single page applications in JavaScript. They can do amazing things, but we have to ship all that code to the browser. And sometimes what we want to present to the user can't even be displayed until that code is downloaded in the browser. So we're not moving away from building single page applications, but we are re-looking at how we serve them and how we get them to our users. And so by taking the Jamstack approach, what we do is we start to pre-render all of our pages in just markup. So a user can immediately see content without having to wait for the actual JavaScript of our application to load. And so that's kind of the idea behind Jamstack, is figuring out a better way to serve our content to provide better performance and a better user experience. And outside of just of our users, serving content to the web that is going to be more crawlable by search engines. We have this great idea, right? That's the point of it. We want people to be able to get to our product. Well, we need to make sure that we are serving what search engines need to help people looking for our product to get to it. And so when we start to take a look at optimizing our applications using different approaches, or the Jamstack technique, that's kind of at the core of it. So, Jamstack is definitely kind of a philosophy and approach. You can't really call it a true stack because it really doesn't care about the technology under the hood. It's just the ways you're thinking about serving it. But Jamstack goals are, number one, better application performance. The larger applications grow, the more they scale, the more cognizant we need to be about how much code we're sending to the browser and figuring out how to fine tune that to give our applications better performance. We care about easier scaling, being able to deliver our product to even more customers, because that makes money, and yay capitalism, haha, just kidding, but relevant for this conversation. We also care about an improved developer experience. I don't know about you, but I'm definitely like a developer. I'm not a DevOps person. And so I enjoy solving problems in code and not necessarily about worrying about configurations or making things work. I just want to solve cool problems and build cool experiences for users. And so the Jamstack does try and offer an improved developer experience for building and shipping applications. Jamstack also looks for, a goal is to have heightened security by approaching the way we handle like making API requests, for instance, or not necessarily making requests when we don't have to, are a part of how we can increase security there. So if we take the Jamstack part of the equation and apply that to an Angular application, what we have. So for an Angular app to be successful, what we want is improved searchability over our competitors. We want our users to be delighted by great performance, and this is how our businesses can benefit immediately. There's all sorts of research over bounce rates and click rates and how quickly you can lose business if somebody comes to your website for a product and they aren't able to get to what they need right away. Google has some metrics around Lighthouse and its recommendations of page load times and first contentful paint and everything like that, but they don't really give you specifics. So if you think that your company could benefit from a Jamstack approach or taking this approach to improving your performance, this is something you might want to sell is, hey, we need to perform this, and we do need better metrics, but the number one metric we need is better metrics than our key competitor. That's what really matters. So as long as you're able to serve your content to a user faster than one of your competitors might be able to in the browser, that's going to boost you in your search engine optimization and please your users as well. So when you start to talk about applying this in a business sense at your company, getting some funding or some budget behind making this shift to improving your Angular performance, like it helps to kind of relate to business people. Hey, there's a real dollar amount attached here. There's a real way we can build more revenue for the company if you let us take the time to improve the performance of our application. So that's kind of your very brief crash course into Jamstack, why we care about it, and the kind of problems that we're going to try and solve, or questions that we need to answer. So where does Scully come into this? If you've heard of Jamstack before, it's very, very likely that you have heard about it because of a little project called Gatsby. Maybe you've heard about it from Netlify. And so Gatsby was definitely my first introduction into Jamstack. My own personal website I had in like Jekyll, because that's what we did in the old school days. Didn't update it forever. And then I wanted to write some new SaaS. And I was like, okay, it's 2019 or whatever. I should not be having to fight with something to like just allow me to easily compile SaaS and serve it in an application for local development. What's the new thing that kids are doing? And so I started looking into Gatsby. And so was React based, and I'm not a React developer, I'm an Angular developer. But what I was able to go ahead and convert my website and then get introduced to the concept of Gatsby, which is where I was building a dynamic application where I could, load in my data dynamically and build out my templates from there and scaffold everything. But then what actually gets served to the browser when I deploy my website is just static HTML pages that have been generated. So my website loads really, really fast, and I get to play with my Lighthouse performance scores and see everything go to green. So Gatsby has been a really, really great tool, and React is a smaller bundle size shipping already in a lot of cases. And so one of the flack we get on the Angular side is, oh, you have to ship so much code to the browser. So by taking the Jamstack approach and making it usable for Angular developers, we've eliminated a lot of that problem, because we can wait on serving all of that Angular code until we at least have something displayed to the user. So that brings us to Scully, which I like to call the Jamstack toolchain that Angular developers have been craving. I'm going to walk you through a basic introduction of how to use Scully, how to get started, and a couple different problems you might need to solve as you encounter trying to increase the performance of your Angular application, and consider how it's getting served and how search optimization is playing in. But the docs are available here at scully.io. This is an open source project, so great team behind it. They're always open to feedback, and they do have a roadmap published. So if you're looking to find an open source project to contribute to, I'm sure they would welcome anybody looking to get involved and bring more value to this tool that's really great for a lot of people. All right, I've got a couple demo apps for y'all. Again, as I mentioned, very into Animal Crossing. Somebody actually built an Animal Crossing API that'll give you like all the villagers and all the insects and the fish and the fossils and all sorts of things. So I use that API to kind of hit against and build my sample application. So I have what's called this little Animal Crossing field guide right now. So this is what you would hit at that link. And so what this is it's a silly little app where I can go, I can load all of the different villagers, I can click into them, I can see more information about them, like what their personality is, what their birthday is, all sorts of things. So for the purpose of this demo, we are going to pretend that this is a product website, and maybe we have a consumer and they are looking for a specific Animal Crossing villager. And so if we want to get them this villager, this product quickly, we want to make sure our website loads as quickly as possible, and that we have the appropriate tags in place for search engine optimization, so people can get to our application and view our products or our villagers faster. So that's kind of the frame we're going to look through this in. So the demo app is available here, and then I do have a repo. If you're like me, I have to like pull down and play with the code and get my hands dirty. So that repo is available here if you want to clone and play around with it, or see the different steps that I took at each stage during this presentation. All right, so what we're going to do is we're going to take this Animal Crossing field guide where we can display villagers and fish and insects. And we want to do a couple of things. Number one is we want to first improve our performance by pre-rendering all of our application pages. So we want to take this very dynamic code base where I am making a request to a third-party API to populate all those villagers. We want to take what's happening there, we want to pre-render it, and we just want to serve that static HTML page in the browser while we load the Angular code in the background. So that way users are going to get to it faster, search engines are going to pick it up faster. Number two is we want to make sure that we're improving our SEO by adding custom metadata tags to all of our pages. So if you're not familiar with SEO, this is where we have like a title tag and a keywords tag, and we might have like an image. So if you have ever seen like an article posted to Twitter or Slack and it has that image pop up, those are all sorts of different meta tags that help us serve content and tell you know, crawlers, hey, this is what this is what it refers to. And so I feel like this is something we skip over a lot. And then when you start building dynamic applications, you're not necessarily sure how you should be updating those things. So we'll look at how to do this in Angular. And then our final goal is to additionally try and improve performance by caching API calls. So in Animal Crossing, I think we have like 315, 317 something villagers, and they stay the same. And maybe if your company has products and those products are fairly, you know, consistent where you're not making a lot of changes to them, you may not necessarily need to be hitting this API and recalling the data every time. So what we can do is we can look into improving our performance by caching certain API calls that we know are more static data versus like a to-do app where we know a user would constantly be updating or making changes. So we want to look at tools Scully offers us on how to do that, but also be cognitively thinking about, does this make sense? Is this an API call we should be caching or not for performance optimization? All right, so goal number one, let's talk about pre-rendering our application pages. And this is the kind of functionality that Scully does out of the box, which makes it really, really powerful. So again, this means we are just going to take an HTML page with all of the content that you see here and build that out as is without having to, make in API call or anything like that. Just have that there and available for the users, serve statically, and then load our Angular code in the background. So for instance, I see this page. I lost my mouse. Where did my mouse go? All right, there it is. I click into this, and then that click functionality based on the Angular router will be available by the time my user is ready to interact with it. All right, and this is just kind of a screenshot of this demo app and how it works. All right, so number one is we need to go ahead and get started with Scully. So what we can do is we can install this. So let's say you already have an Angular project that you've started and you're like, hey, we really need to improve performance. We want to serve these pages. We want to improve SEO. You can just use the ng add command to do Scully /init. A couple requirements here. Scully is only going to work on Angular version 9 and above. There was a big compiler engine rewrite, and so that's a big part of it here. So if you are on a lower version of Angular, you will not be able to use this, but it's best practice to be upgrading as Angular upgrades as well, which on their typical roadmap is about every 6 months. So definitely good incentive for you to recommend your company to invest the time and effort in upgrading Angular. I know at my consulting company, Bitovi, we help our clients a lot. Like we've taken a lot of people from like Angular 7 to Angular 12 to kind of get them on the right page and reaping all the benefits of the great code that the Angular team is pushing out. So anyway, so for Scully, if you want to use this, you need to be on version 9 or above. And if you are on version 9, 10, or 11, you need to use Scully version 1.1.1. Again, the best practice here is to keep up to date with the latest versions of Angular. And so the Scully team and other key frameworks in the Angular ecosystem are going to continually upgrade and try and be pretty in line with Angular. So you don't just want to worry about upgrading Angular. The other libraries you might be depending on, like NGRX or NX or something like that, it's best to keep those all in sync. So if you are in Angular version 12 already, you can use Scully version 2 and up. And then you do need to have Node.js 14 or higher. I am a consultant, which means I am always hopping code bases and code versions. So I live and die by NVM. So it's a really useful tool if you have not heard about it. Node Version Manager allows you to install and switch between different node versions really quickly. All right. So number one, when we start to implement Scully, what Scully is going to do is to pre-render all these pages. It needs to know what pages that we are going to care about displaying to the browser. And typically in any single page application, you are going to have a list of routes. And those routes are going to define, what your different pages are in the application. So if we look at my example application, we have a route that is villagers and then a parameter, which is the ID of the villager. Or if we just want our list of the villagers, the route is here. So your Angular application needs to have routes for Scully to work, because it's going to look at your routes and then it's going to say, okay, I'm going to create this page for this route and this page for this route. And I mention this because when I've helped customers use Scully before and they had something goofy going on in the router, they didn't realize this is kind of like the starting point for Scully to read what's going on. And so you might get a weird error if you just have no routes in your Angular application. So that's how it's going to work under the hood. So in my example application, I have a list of routes. It's going to look something like this, where I have a path and then whatever that component is. So for the context of this demo and what we're talking about, these are all my different routes that I care about. So villagers route is going to display my villagers component. My villagers / whatever parameter is going to display a specific component for a villager that's going to, from the API, call specific data about that villager by passing in their ID. So that is kind of what my application looks like in a nutshell. All right, so the number one thing we need to do after we've installed Scully is we need to run the ng build command. So the ng build command is going to take your application and it's going to minify it and build it into a dist directory. So this is a really important step to understand what Scully is going to do. So we're going to build, make sure that everything is our dist directory, that we didn't have any compilation areas, and we'll be good to go there. All right, from there, we are going to run the command npm run Scully. And so this is going to do a couple things. One, it's going to go troll. It's going to look at our Angular application routes. And then it's going to try and spin up all of those routes. It's going to serve the application from the dist folder. It's going to try and hit all those routes. And then essentially what it's going to do is it's going to use Puppeteer to spin this up and then kind of scrape everything rendering. So it's going to go through, it's going to navigate to each of these routes provided, and then it's going to kind of capture everything that's on that page, copy all that markup, and then slap it where it's being served for our pre-rendered version. So that's why it's very important to understand the context of the build command, what you're doing there, and then what happens when you run Scully. So anytime you make an update to your application, like let's say you made some changes to add meta tags or something like that, you're going to need to rerun the build command to make sure that code is captured, everything is in the dist directory, and then Scully is going to run against that, load everything up via Puppeteer and scrape and get whatever's there. So that's very important context that, again, a lot of people don't understand when they're first getting into this. All right, so when we run our Scully command, we're going to see for the first time something that looks a lot like this. Scully's going to go, it's going to say, oh, okay, I'm looking at your routes. These are all the routes that I found, and I was able to just do these as is because there's nothing dynamic going on. I can simply go to this application, I can navigate to /villagers and see exactly what I need to see in the browser. Then you might see something like this. Pull in data to create additional routes. No configuration for route villager /ID found, skipping. And the reason for this is it's reading this parameter and it's like, I don't know what that is, so I can't just put anything in there and render it in the page. You're going to have to give me instructions for how to do that. And then finally, it's going to create a couple files for you of all of the routes that it was successfully able to map. And so it's going to be this output of this Scully routes.json, and it's going to give that to you in your main directory as well as your dist directories. All right. So the next thing we're going to do is we're going to run serve and to serve our application. And so when we do npm run Scully serve, it's going to boot up 2 servers. It's going to do the first one, which is going to be pointing at our dist directory just as is. So if we just had our regular production build, that's going to be served there. And then the Scully server, where it's taken all these files and basically created index.html files for each of the pages that we care about, are going to be served out of a different directory to different ports. So you can go back and forth and kind of see what's been done and troubleshoot there. Okay, so now that we've talked about kind of how Scully is doing things, let's get to the dynamic part, because this is a really common use case, right? Basic CRUD application, where we might have a list of things and we want to navigate to that thing /ID and then pull in specific data because we're making an API request. How do we go about figuring out? So like I mentioned, there are, 315, 317, 319, I can't remember what the count is, villagers in Animal Crossing. And so for this to work properly, I need a page for each one of these villagers to be rendered in the browser and then to have that HTML file served for each villager. So we need to give Scully some instructions on how to figure out how to do this. All right, so number one is Scully has a plugin system. There are some built-in plugins that are ready available to solve a lot of problems, but you can write your own plugins to solve any number of problems. I've been in some situations before on clients where you have to make multiple API calls to get kind of that list generated of what you want, and so you can write your own plugins to fulfill that. So there are a couple main types of plugins. We've got a router plugin, a render plugin, and a file handler plugin. And a lot of these are already built in and available for you to use. So what we're going to use initially for our dynamic routes, so every time we want to generate a page for a villager that's a specific ID, we're going to use the JSON plugin. So one of the files that was created when you ran ng add Scully init is the Scully config file. And so you're going to see some sort of export like this, where we've got our Scully config, where we're passing in a lot of information. So let's say you are in a different project structure and maybe something squirrely has happened and your project root where your source files are isn't actually out of the source directory. Here's how you would change that to look for the routing information. Let's say there was a different output directory you would configured. This is how you would change that there. So this is kind of like the defaults generated for you. Now this routes this routes member is where we're going to do a lot of our work for creating our custom routes. So this is where we need to go and say, hey, Scully, for all these routes that you didn't know what to do with, we're going to provide instructions for you. All right, so what we're going to do is implement a new route config. And I pull this out because a lot of times when you're reading through the docs, it's not explicitly clear. And so I just have the repo cloned locally, and that way I can click around and use my editors and IntelliSense to go and find interfaces for what I need. So I understand the type of what everything should be and what something should look like. This was really helpful for me when I first started developing, Scully applications, because I didn't quite know what I was supposed to pass and where. And so this is that route config. If you're going to provide instructions for a route, it's going to expect a string of what that route is. So for example, our villager /:ID for our dynamic routes, that's what we would pass in here. This type is going to take whatever plugin that we're using. So in this case, we're just going to use the provided JSON plugin. We've got our post renders here, which will take another string. And then for this, this is a little weird. So what we need to do is we need to figure out all of the villagers that we need to render pages for. And we have this API, and if we call just get villagers, it's going to return us a list of all villagers. So what we can do is we can hit that API via Scully, and we can get back that list of villagers, and then we can return anything we want there. So what this is going to do is when Scully looks at our route, it's going to hit that villager /:ID route, and it's going to say, okay, hold on. Then we're going to execute this function that's going to go make an API request to whatever URL we pass. So it's going to go hit that. It's going to return a list of villagers. And then I know that I need to create a page for every ID of every villager. So what I can do is I can return an array of IDs. And then all of a sudden, Scully has instructions. Hey, go navigate villager /1, execute that code. Hey, go route villager /2, execute that code. And there we can dynamically build out our pages that way based on whatever information. So if we have, an ever evolving list of products that we're offering to our services that we are selling via our application, anytime we run Scully, we make a request to the API, we're going to get a list back of all our products and be able to build out any relevant pages to that. So in practice, that code that I just described is going to look a little bit something like this, where this routes is taking our route config. I'm passing in the specific route that I want to provide Scully instructions on how to handle. And then I'm using our JSON plugin, and then this parameter here is whatever I care about returning. So I want to return that /ID. That's the information that I'm providing to Scully. So I'm passing in my API call here. I'm going to return the property ID, and there is an additional results handler here. So it's going to take the response of whatever URL you pass in and allow you to do something with it. This API is a little bit goofy. Instead of returning like an array of villagers like I would expect, it returns an object, so you can do direct gets. And so I'm just mapping that out to make it work. And that is what that is looking like. All right. So once I have done this, now when I run my Scully command again, and this is just making changes to the Scully config file, once I run this, all of my, 391, that's how many it was, pages are going to be pre-rendered because I fetched the IDs for all of those different villagers from that API call, and Scully has gone navigated to each one of those pages and scraped the content from those pages as they were loaded up via Puppeteer. All right, so a couple really common community plugins that you might want to be aware of, Minify HTML. So this is kind of a performance optimization to even further reduce the amount of code that we're serving to the browser. Disable Angular, TOC, lazy images to help you better handle loading images and creating sitemaps dynamically. So a lot of great content already out there and available for you to continue to add this functionality that dynamic single page applications have when you are serving them like as static index.html files. All right, and actually one thing we should look at, just so I just want to make sure this is really clear to people. Okay, so when we run our Scully command, here's our dist directory. The name of that directory is where our like just normal old Angular code is going to be compiled to. Here's the static directory, and this is what what Scully is going to create. And so every time it navigates to something in our router, it is going to create an index.html page for that. So here's like our base one, that's the base of our application. And in our villagers, it's going to create, sorry, as I scroll forever, it's going to create a villagers index.html. So when you navigate in the browser to /villagers, it's going to serve this index.html file. If you go to villagers / for instance, 382, it's going to serve the index.html file inside of this. So it's like old school, the kind of stuff we'd put on FileZilla back in the day, right? Way of serving a web application. And I see a question: how does Scully interact with the TypeScript of a component? Scully doesn't explicitly yet. In the scenario that we've talked about now, what is happening is we are using Puppeteer to serve our Angular application, and all Scully is doing is copying everything loaded in the browser at that point and slapping it in an index.html file. So it doesn't care about our TypeScript component code because it doesn't need to. It's just taking whatever like a user would see that TypeScript code has like, you know, wired up in our component. So let's look at the source code I have here for an example. Let's look at our villager component. So this is what we get when we navigate to villager /1, for instance. So in our onInit lifecycle hook, I am making a call. I'm getting the route param, and then I am passing that to a service, which is making a call to the API to get the villager that particular ID. And then inside of my component, that's an observable. I am subscribing to that, and then I am writing out all this information as you see in the web application. And so the TypeScript component has generated all this. Okay, and this is what we're looking at when Scully runs, loads up Puppeteer. Puppeteer looks at this page that's already created because everything is run inside the component, and it takes all of this and slaps it in an index.html file. All right. Sorry, this is like weird to click with Zoom. All right, so that is how we deal with handling dynamic routes and being able to render different pages. All right, so let's talk about our goal number 2. This is great. We are now able to just serve static HTML pages to the browser so search engines can pick them up quickly. But this is a single page application, and I only have that one TypeScript component that's serving all of the pages for the different villagers. So what I need to do is I need to add custom metadata tags to my application pages. So when I'm at villager /1 or villager /2, that I'm providing SEO data that this is the page for Antonio, and maybe some keywords like his personality or his gender or his species, which is anteater. All right, so spoiler alert, this is built into Angular. This is not Scully specific, but it's relevant as long as we're talking about making more performant and more searchable Angular applications. So there's already something included in Angular from their platform browser module. We've got the meta and we've got the title services. All right, and so all we need to do for this is that same code that I just showed you, where I am getting the param from the application. That's the ID of the villager, and then I am making a call to that villager, and that's the value of that is being set to my villager, which I'll create a subscription to in my template. So I need to do some like manual code here to update other things. And so we've got title tag and we've got meta tag service. So title tag is going to allow us to dynamically set that title of the page. And so here I can just call the set title method, and then I'm just passing in information from the response of this API. So I want to set the title of this page to be my Animal Crossing villager's name. And so that's how I'm getting that. Then we have the meta tag service. And this is a method that takes an object. And so this object is going to have the name for whatever that meta tag is, and then the content. So for instance, I want to set keywords, because if somebody is searching, I want to make sure my content is coming up based on specific keywords. So I'm saying, okay, the content there is Animal Crossing's New Horizon, then whatever my villager name is. I might also want to do that for my description of the page to give a search engine, better information about what this page actually is. Okay, this is information about the Animal Crossing New Horizons villager name. And maybe I want to set an image meta tag on there so I can actually pass in the URL from the API that'll load up that villager's image when somebody searches for this page. So this is really cool. And so this code is going to execute when we reinitialize this component. And so when we navigate to this, it's going to make that call to the API based on that route param ID changing. And then all of this is going to re-execute. So the thing to look out for is you want to call update tag versus set tag on the meta tag service, or you're just going to keep slapping tags on the page, and that might not be what you want. It's something you might miss easily. So update tag, and that's just going to take whatever tag that you care about and swap out the content of it for the new content. So that way, as we are clicking between, different villagers, the title, and if you saw this tab change here, the title is changing as we click on different things, as well as the meta tags. You'll just have to believe me, that's happening under the hood. All right. Okay, if you're unfamiliar with meta tags or how they work, this is a really cool tool that I use a lot called metatags.io. And so you can basically just pop this up and slap your generated URL in here, and it's going to check and show you kind of a preview of what things are going to look like in a search engine. If you're doing social media tags like Twitter or Facebook, it'll show you what it looks like there. So kind of a cool tool. All right, so let's talk about goal number 3. Caching our API calls. All right, so like I mentioned before, I'm dealing with fairly static data here, where new villagers, at least I don't think any are going to be added. We do have a new update coming, some downloadable content, but I don't think new villagers are on the roadmap there. But this content is going to be fairly static. And so I don't necessarily need to be hitting this API call every time. And so one of the things we can do is we can look at caching this call so a user doesn't have to wait on that response every time, and maybe we're saving ourselves a little bit of money in the process. So for this, we can use something called Scully transfer state. So Angular already offers something to do this called transfer state, but in my opinion, it's a little bit verbose. So I just have to do a lot of management of this on my own, versus Scully makes it very easy to use, in my opinion. All right, so this is inside of my service. This is where I have all my methods to make API calls. So let's say I've got my get villagers call, and this we've deemed to be pretty static, right? It's pretty much always going to return these same 391 villagers. What I'm going to do is I'm going to create a key, make a state key, and this is all native functionality to Angular. I'm going to call it villagers, and then I am going to basically, if there's no cache response, like if I make a call and say, hey, key, give me this value, if there's no value there, I'm going to go ahead and I'm going to make this API request. And then when I get that request, I am going to set that state with my villagers key and the responsiveness. So that way, if there's no cache response, it'll make the call, but if there is a cache response, it'll just keep what it has already in state. All right, so it's okay, it's a little verbose. I really like Scully transfer state. It just makes things a lot easier to deal with. So we can import transfer state service from Scully. And then here in our same method where we are making this get request, all we need to do is return this .transfer state .use Scully transfer state, which is a method which is going to return an observable, just like we would be dealing with HTTP client. And so it just simply takes in a key for the name, takes in the API call, and it handles the rest of everything for us. So this is a fairly low maintenance solution to implement if you are looking through your application and you see that there are some API calls, maybe it makes sense to cache. And so what happens is Scully is going to look at this code when you have run a new ng build. It's going to look at this code. It's going to say, oh, okay, hang on. They're using transfer state. So I'm going to take this call and I'm going to slap it in a data.json file, and I'm going to serve that instead of making an explicit HTTP request when a user goes to navigate to that. So that you can see looks like this. So that's exactly what we did for the villagers. And so alongside this index.html file, it generated this data.json file, which is just basically a grab of everything that came back from that API call. And so we can just load this data.json file instead of making a separate request to the API. All right, so all things said and done, if we start to, run Lighthouse, which is not the end all be all of performance assessment, but it can definitely be a good check-in point to get you in the right direction. We can compare and contrast our Angular dist versus our Scully static version and see our performance start to improve because we are serving just markup to the browser that is automatically going to load in images and content instead of excuse me, having to wait on an API request for that, and loading in some of that data initially from a locally served data.json file instead of having to call out to a different server to make an API request. Okay, so I want to share some debugging tips and tricks with you. You know, Scully is an open source library maintained part-time by a really talented, amazing team. And so there are a lot of tips and tricks that they've actually given me to help debug applications that can help you out. Like I remember I had a client and some of their routes just weren't rendering. And it was really hard to debug. We couldn't figure out why. Turns out guest parser, which is one of the libraries that Scully is using to try and read and then interpret the Angular routes, could not handle routes that were being created using the spread operator. And so all sorts of weird little nuanced situations that you might get into over time. And so hopefully these will help you out. All right. So number one, I mentioned this earlier, but I would really recommend cloning the Scully repo. It's just really quick to get access to different interfaces or things that might not be explicitly documented, so you can see exactly what Scully is expecting. You know, it's just I'm just much more competent in my IDE than I am in GitHub or something like that. I can just get what I need much faster than clicking around. So I would recommend just cloning the repo locally and being able to use your editor's IntelliSense tools for that. One of the other things you can do is take advantage of incremental rendering. When you do npm run Scully, it is going to look at that list of routes and it is going to render everything it can find. And so if we look at my example application, this is 391 villagers. And so it's going to load up each one of those routes in Puppeteer. It's going to crawl, it's going to slap that in a file and move on to the next one. So you could be loading like 600 pages. And this is just like a goofy little side app, right? This is not something actually trying to sell anything. And that's a lot of routes and a lot of time to create. And so when you're first debugging Scully and getting things working properly, what you can do is you can incrementally render things. Instead of rendering all of the routes, you can just say, hey, pass in this base filter flag and just say, okay, I only want to render everything behind the villager's path or something like that. And so that way you can just do that and not like all the fish and all the insects and everything else I have in the field guide. So that can save you a lot of time. The other big thing is understand how Scully is rendering. So remember, Scully is going to take your built project. It's going to, you know, run that in Puppeteer. It's going to like look at that exactly how it's displaying. And then it's going to take those pages, take all that HTML, slap it and dump it in that new directory. It's black magic happening, right? Like you don't understand what's going on. And so something really helpful is you can run this show browser flag. And so that way, instead of running headless, you can actually see what Puppeteer is seeing. Sometimes there'll be timing issues where maybe there's some weird third-party JavaScript plugin running and it's preventing the page from even being rendered. And so Puppeteer is just like, whoops. And so it just takes HTML from like a blank page being rendered, and that's what it slaps. That can be really hard to figure out. So you can run show browser, you can see exactly what Puppeteer is seeing. And the other good thing to know is you can run the Scully command and pass in any of the Puppeteer arguments. So if you're already familiar with this, this tool, you can pass any of those arguments and they will work just fine to help your debugging process. Like I mentioned before, I've seen weird issues with the router. And so one of the flags you can pass in is show guest error. And so the guest parser library that Scully is using under the hood, it'll output errors for that. And that can help give you better errors instead of just like a silent failure or whoops, don't know what to do with this route. So those are really, really helpful tricks for what's going on. All right. So I've only got a couple minutes left. So in summary, Scully rocks for jam stacking Angular. This allows us to use our JavaScript, you know, use our Angular application as is, use our APIs as is, or maybe think about caching them, but then taking all of that content that creates, all that markup, and serving just static index.html files to the browser, and then our Angular code loads and people can see stuff right away. We're generating static pages for our application. So this is like static page rendering that we serve via CDN or something like that. It's different than server-side rendering, which you may have heard of with Angular Universal. We are able to generate pages from dynamic routes using Scully plugins that are available. That's how we got all those different villager pages to render. We can add SEO content using the built-in services from Angular, the meta and title services. And we can use Scully transfer state to cache API calls if we deem them stable enough that it makes sense to cache. If you have an API call that is, currently returning different information, probably not a good idea to cache that but for anything that's, more static, that would be a good thing to do. And then if we're debugging Scully, trying to, get things to work as intended and getting our feet wet, adding Scully to an application for the first time, we can use different CLI arguments of different Scully dependencies. All right, so here is a good slide for you. This is where the demo is at. That's where the code available is at. I've got a couple articles on Dev2 that cover some of these pieces more in depth with code samples. So definitely feel free to check those out. And the slides are available here. So if you just want to take like a screenshot or whatever of this page, you can go here and then click to all the links. And we've got 0 minutes left for questions. I do have a random question that says, does it play nicely with NGRX? I mean, yes, because NGRX is going to do its thing. And so at whatever point that Scully is calling a route and navigating to a component, Scully doesn't care like what you've used under the hood, because that's just scraping what's available in Puppeteer at that time. Yeah. All right. Any other questions? All right, well, that is all I have for you. Thank you so much. I hope this was informative. I hope you can get your Jamstack on after this, and have a great rest of your conference, you wonderful human beings.